complex numbers, and this is where we introduce the letter I in math, an imaginary number. So, for a while we've been saying it's impossible to do a square root of a negative, but it is possible when you have imaginary numbers. So, here's something you always want to remember. So this letter I, when you square it, it's the same thing as -1. And then, so if I take the square root of -1, it is going to be I. Alright, then there's other things to remember about I. So I equals I squared equals -1. I to the third, if you multiply two i's, it makes -1, and multiply another I, it makes a -I. And then I to the fourth equals 1. This is something you want to write somewhere on your notes because later on they're going to talk about how this is useful to know. And complex numbers, when you have complex numbers with plus and minus, there's this form a plus bi. So this is saying you write whatever the number is first, and then you write the I, and then the I comes next after a plus or minus. It's just an order they expect most of in books and math textbooks and everything. So letter comes first, then the I, and it's important this order later on because in pre-calc we'll learn next year, or calculus, we'll learn about like how it looks visually in a 3D dimension. Alright, so let's talk about, let's go over the problems on 7a. So number 1, it's asking what is the square root of -1? Pretty much on your notes, square root of -1 is I. Number 2, square root of -49. Alright, so I'm going to break this down. The meaning of -49. So basically I have -1 times 49. We know the square root of -1 is I. And we know the square root of 49 is 7. So I times 7, that is 7i. Let's go over number 3. We have square root of -64 x to the 6th. All right, I'm going to go ahead and break this down apart. So I'm going to do -64 times x to the 6th. So always remember, so a little shortcut here. Anytime you take a square root of a negative, there is going to be an I. So if I take square root of -64, I know there's going to be I, so I'm going to take square root of 64, that's 8. Okay, always remember, negative, got to bring down the I. Alright, then we have square root of x to the 6. Remember, the root of a square root is 2. So we're asking how many times does 2 go into 6? That's 3 times, so we have x to the 3rd. Alright, so how I'm going to write this answer is I'm going to put 8 x to the 3rd first, I comes last. So the answer is 8x to the 3rd I. Number 4, we have square root of -121 over 144. Alright, we're taking a square root of a negative, so I is going to come out automatically. I'm going to go ahead and rewrite this. So square root of 121 over square root of 144. So when you have a square root of a fraction, and you can tell you have a perfect square top and bottom, that in other words you can square root this number, you can square root this number. That's what you just do, you just take the square root of this number and just take the square root of each one then. 121 is 11, square root of 144 is 12, and because we had a negative, I comes out. There's an I. Number 5, we have square root of -4 plus square root of -100. Alright, so we have all these negatives. So that tells me I is going to be coming out of them. So square root of 4 is 2, so I have 2I. Bring down the plus. Square root of 100 is 10. It's a negative. Bring in the I. Both of them are I, so I can add these. 2I plus 10I is 12I. Right, number 6. We have 2 square root of negative 9 plus square root of 36. I have a negative in the square root, so that tells me I is coming out. Now keep in mind this is 2 times square root of negative 9. So I'm going to put, so I have 2 times, we know I is coming out, and then square root of 9 is 3. So 2 times 3 is 6, so I have 6I technically here. Right, this one I don't have a negative to take out, so a square root of 36 is 6. Alright, so 6I plus 6, what I really want to write it as though is the number first, because it's a complex number, so the number comes first, the I comes next. So this is the correct way to write the answer. Alright, number 7, we have square root of negative 20 x squared. Let's break this down. So again, I can see i's coming out, so I'm going to bring the I out. Because of that negative, I is definitely coming out. So we have to do square root of 20 and square root of x squared. Alright, what's a perfect square that goes into 20? We know is 4. 4 times what makes 20? 5. I'm going to circle the 4 because that's my perfect square. And it's going to go out there. What's the square root of 4? 2. And then what stays inside is the 5. Stays inside the square root. My little way of writing it quickly, the whole square rooting thing. The simplifying the square root. Alright, square root of x squared is x. Alright, so how am I going to write this? So I'm going to put 2x square root of 5. Usually the I goes last, but sometimes it goes in the front too, so I'm going to put it right here. 2xi square root of 5. Alright, so number 8, we have square root of negative a plus square root of negative b. Alright, so all these, when you have a negative in the square root, you know there is an I. But, okay, we can't take square root of a. If it was like a squared, we could say it's a, but there's nothing we can multiply twice to get an a. So I'm going to take I out, and I have square root of a. And over here, i's coming out, and I just put square root of b, and it's done. That's all I can do. I cannot add these because inside the square roots are different letters and different things, so I can't do it. So if it was different letters and different numbers, you can't combine these at all. Number 9. We have 3 square root of negative 12 plus 4 square root of 162. Alright. There are negatives in the square root, so there is an I. So I'm going to just take the I out automatically. Just breaking it down here. Alright, so what's a perfect square? There are perfect squares that go into these numbers. 4 goes into 12 3 times. So I'm going to have 3i times, what's the square root of 4? 2. What's going to stay inside? The 3. Over here, so 162. So I'm going to just go divide by 2. If I do 162 divided by 2, I get 81. And 81 is a perfect square. So I put 81 times 2. Alright, so I'm going to bring down the 4i. Square root of 81 is 9, and what stays inside is the 2. Alright, multiply your outsides. 3i times 2 is 6i. Bring down the square root of 3. 4i times 9 is 36i. Bring down the square root of 2, and because what's inside the square roots are different, you can't combine them, so you are done. Alright, number 10. We have 13, square root of negative 1, minus 2, square root of negative 81. Alright, we got a negative inside the square root, so i's are definitely coming out. So we have 13i, square root of 1, minus 2i, square root of 81. Square root of 1 is 1. And then square root of 81 is 9. 13i times 1 is 13i. 2i times 18 is 18i. Both of them are i's, so we can actually subtract these. 13 minus 18i is negative 5i. Alright. Number 11, we have 2 square root of negative 25 plus square root of 16. This has a negative. This one doesn't. So this one, i's coming out. This one, there's no need of an I. So I have 2i square root of times square root of 25 plus square root of 16. Square root of 25 is 5. Square root of 16 is 4. 2i times 5 is 10i plus 4. Now remember, if you want to write the answer correctly in complex form, it's really 4 plus 10i. Alright, number 12. We have square root of 3x squared plus 4i squared. Alright, so we can't take square root of 3. We can't take square root of 3, but we can take square root of x squared. So go ahead and break this down here. Just breaking it apart, numbers and letters together, so square root of 4. Alright, so square root of 3 we can't do, but we can take square root of x squared, which is x. So I have x square root of 3. Here we can take square root of 4, that's 2. And the square root of I squared is just I, and that is all you can do. Alright, so number 13 through 16 goes back to the importance of knowing I to the first equals I to the second equals negative 1, I to the third equals negative I to the fourth equals 1. And I'm going to show you why. So number 13, we have I times I times I times I. How many i's are we multiplying? 1, 2, 3, 4. So we have, it's just I to the fourth, and I to the fourth always equals 1. Alright, number 14, we have I times I times I. So let me so we have 1, 2, 3, 4, 5. And then times I to the third. So let's count how many i's do we have. So I'm going to group 4 of them together because that means, because we know I to the fourth equals 1. So this is 1. And then we have I to the first times I to the third. Remember, when you multiply exponents, you add, so 1 plus 3. That's also 1. So then 1 times 1, it's just 1. All right, let's talk about 15. So we have I to the fifth. And we already know that I to the fourth would be 1. So watch how I rewrite this. I'm going to put I to the 4th times I, because 4 plus 1 makes that 5. So technically we have 1 times I, which just equals 1I, or just I. Number 16, we have I to the 3rd and a 3 outside. So an old review, when we did exponents, when there was an exponent inside or outside, we multiply them. So 3 times 3 is 9. All right, let's write that in relation. So the highest number we have here is I to the 4th. So I to the 4th. Oh, this is going to take a while. All right, so I to the 4th. And then we have I to the 5th. All right, so I to the 4th is 1. We can break down the I to the 5 too as I to the 4th times I to the 1st, because 4 plus 1 makes that 5. So then we have 1 times I. So our answer is just 1I. Now there's another way I could have done this. I could have done long division. So we have 5. I just put the highest number, so we know I to the 4th is 1. I'm just going to go, okay, how many times does I go into 5? 1 time. So I minus 4, and then my remainder, is 1, so it's just I. I to the 1st is I. Over here, if I went 4 into 9, 4 goes into 9 2 times, and my remainder is 1. So then I get I to the 1st, which is just I. So that's another way to do it. I just broke it down in this way. I know some don't like long division, but honestly, I feel like long division is the quickest way. When you see a remainder, you know what it's going to end up being. All right, number 17. We have 15I times negative 8I. All right, so I'm going to do my numbers. 15 times negative 8. That's negative 90, I believe. Yep. Nope, I'm wrong. Negative 120. Wrong right there. All right. And then I times I squared. Now remember, I squared is negative 1. So technically I have negative 120 times negative 1, which is 120. Number 18, we have 3I times square root of negative 169. Remember, anytime you take a square root of a negative, an I comes out. Oh, gotta be careful with this one. So I have 3I times, when that negative comes out, I have an I, and I'm taking square root of 169. So now I have I times I is I squared, so I have 3I squared times, what's the square root of 169 is 13. Now, oh, be careful with this one. I squared is negative 1, so negative 1 times 3 is negative 3. So you have negative 3 times 13, that's going to be negative 39. So you got to be careful whenever you get an I squared and make sure you're aware whenever you can get an I squared. Like here, when the I came out, I had to do I times I, and that gave me I squared. But then when I do I squared, that's negative 1. So instead of a positive 3, I have a negative 3, because negative 1 times 3 makes the negative 3. And then I do negative 3 times 13, and that gives me negative 39. All right, let's go ahead and do number 19. So we have square root of negative 6 times square root of negative 6. So automatically, you see these negatives, I is definitely coming out. So if I square root of 6 times I square root of 6. All right, remember when you multiply radicals, outside times outside makes outside, inside times inside makes inside. So I times I is I squared. Square root of 6 times square root of 6 is square root of 36. Alright, so I squared is negative 1. Square root of 36 is 6. Negative 1 times 6? 6. Alright, number 20. We have 2 square root of 225. Times 6 times square root of negative 4. Alright, so I'm going to look for any negatives in my square root. Oh, yes I do. I have one. Alright, let's break this down. So, I have 2 times square root of 225 is 15. Alright, square root of a negative. I is going to come out, so what's square root of 4 is 2, so I'm going to have a 2i here. Alright, so 2 times 15, that's 30. 6 times 2i, that's 12i. 30 times 12 is 360. And then bring down the I, and there's your answer. 360i. So just remember, I squared equals negative 1. So if you get I times I, it is going to be a negative. Square root of a negative number is always I. So whenever you take a square root of a square root, I is automatically going to come out. And then this, always remember I to the 4th is 1, and then I squared is negative 1, I to the 3rd is negative I. And that'll help you with the ones where we had to figure out I to what number, how far does it simplify? Does it simplify to I, negative 1, negative I, or 1?